Thank you very much for the intro and for the opportunity to be here today and speak about my work. This talk will be about AI contextual engineering, specifically in the R&D space, leveraging a multi-model database. Since I'm here, I want to first talk about my journey with MarkLogic. I think it has been quite a long journey since 2016, so almost a decade. But even before that, I have already started using, play in the domain of, search engine, graph database, so on and so forth. But you really have to piece together multiple different solutions until I, start using MarkLogic, and that turned out to be a really nice, one single solution with all the required features coming together. So, since we adopt that MarkLogic at DuPont, I was able to lead multiple projects, really trying to build together a enterprise-grade R&D data system, knowledge hub at DuPont. Then I moved on to another company, which was spin off from DuPont called IFF, where we further expanded the use of MarkLogic into other R&D data management tasks, as well as to start integrating with the generative AI. Last time when I was at the MarkLogic World, that was 2020. I was talking about how we implement MarkLogic at DuPont. So unfortunately, that event, like everything else, turned into virtual during COVID. But the good part is that because it's a virtual, we managed to have this YouTube video that's online in case you're interested in how it was done at DuPont. For the last 4 or 5 years, I have had the opportunity to really dive into large language models. So this was actually several years before ChatGPT went viral. I had the opportunity to start working on this domain. So this slide describes the journey we went through. The first, because this was prior to the chatbot, we spent a lot of time really talking about language model for data text processing, such as extraction, summarization. And then since ChatGPT showed us the way, we quickly turned over to chatbot building. But then from there, we kind of start to further specialize in the R&D domain of shifting from AI-based research assistant to more complete AI agentic research workflows. I can't really talk about the AI work I did at work when I was at IFF, but what I can talk about is this open source project that I spent some time build for the last several years. It is essentially a chatbot-based AI research assistant, but it's more than a chatbot in the sense that you have the ability to actually this simulate a workflow when a scientist read a literature, a scientific paper. You will be able to actually interact with the paper, such as ask for explanation, process a graph, extract data from a table. So a lot of the features that today actually you see more and more get used in more agentic flow. So that was one of the interesting projects I did in the space of Gen AI for R&D. Going forward, I have really, really high hope, see how Gen AI is going to play to really empower scientists, R&D scientists. Being a scientist myself, I really can see, I think some of the speakers mentioned this in the morning, is how AI can help us scale things beyond what we can do humanly possible. Such as now with AI, we have the opportunity to scan through vast amount of literature, to screen a lot of different hypotheses, as well as to design a lot of different plans, and really leveraging the latest crop of reasoning model to automate some of the research process, all the way from planning, refining, and so on and so forth. So the topic of this presentation, I will combine two of my favorite things here, MarkLogic and Gen AI together. Now the objectives are, first, I want to explore how Gen AI can make whatever knowledge you have in MarkLogic, if you're already a MarkLogic customer, how can we use Gen AI to make your knowledge in MarkLogic more valuable? The second objective is to go in the other way. how can we use MarkLogic to support other more advanced Gen AI features, such as AI agents. So let's first, well, before we go, actually, I should mention some of the motivation why we would do that. I think by now, you should be well aware about the limitations. I think several speakers have alluded this already. The limitation for large language models, such as hallucination, but also another thing keep in mind is that it still requires a level of a software development because the model is just a model. It takes a standard input and provides some output. You still need to build everything around it to form meaningful either AI assistant or AI agent or AI-based applications. So the way people do that is through what used to call the prompt engineering. That is, figure out a smarter way to put the right information into the prompt that you feed into the AI chatbot. Gradually, that term has evolved into context engineering, which I think is really just a different way, maybe a more systematic thinking or more from the information architecture perspective. How do we structure the prompt so that we feed the right information to AI in the right form at the right time? So again, context engineering is really the key here for us to accomplish what we want to do with the AI. Now it's time. Let's dive into the first topic. That is to make what you have in MarkLogic more valuable with Gen AI. Well, that is a topic I think also covered a lot by many different speakers this morning, because that is called retrieval augmented generations, RAG. Just very quickly go through, in case you missed that, the RAGs stand for, what RAG does is, you start with the user query, you analyze the query, and based on the query to retrieve relevant information out of your database, and then combine the user query with the retrieved information, pass everything to the AI model, and the generate answer. In this way, you're able to essentially grant the model's response based on the context you provided that is coming from your data set instead of the internal knowledge of the model. But to get it right, for R&D use cases, there are several considerations. First, in R&D, we have a lot of heterogeneous data. We don't just have plain text data like web page or newspaper. We have a lot of different data formats. Also, R&D knowledge evolve over time. What we consider to be the truth today would potentially be very different in 5, 10 years later. So we need to account for that temporary change of our human understanding in the scientific domain. The third one is the provenance and traceability. I know it's very important for everything that we want to be able to grant the response based on truth and fact, but this is especially important for science. Lastly, security. I heard several speakers mention security. The R&D information is usually considered the crown jewel of a company. So in making the information more accessible, we cannot afford to compromise security. So that's, I think, really aligned with some of the capability MarkLogic is able to provide, such as with the multi-modality capability of MarkLogic, we have the ability to host various different forms of R&D knowledge, being it a document, graph, or table, so on and so forth, into MarkLogic natively. And it has the triple-based provenance mechanism we can leverage to improve the traceability and governance. Of course, the temporal feature and the security are all very important as built in MarkLogic. The second consideration is about the limitation of the different indexing mechanism. I think we heard about this. I think MJ mentioned this paper from Google DeepMind this morning, talking about there is a theoretical limitation of vector-based indexing in certain retrieval tasks. So that's just a reminder that perhaps we should not prescribe to a single indexing mechanism for our RAG tasks. Another thing to keep in mind is that, in fact, there is a whole lot of different RAG techniques out there. Well, one good thing to know is that you see that deep blue bar at the very top that is getting wider and wider every year. That is the graph-based RAG. So that's a good thing that if you're working with a graph-based RAG, you can see that's definitely gaining popularity, at least when you compare the number of scientific publications covering those different technologies. However, we can see that there's still a lot of research papers being published every year on other type of a RAG system, other RAG methodologies. So again, we should not, in design of a system to be future-proof, we should not limit ourselves to one particular technology, but really need to leave that flexibility, the possibility open to embrace different RAG mechanisms going forward. And that's what I mean is here in on slide talking about how we can use MarkLogic, the flexibility, the multimodality to future-proof your retrieval mechanism. At the bottom, we have all the MarkLogic data in the MarkLogic, but then we can use the modality to support different query mechanisms that really make our system more robust, more adaptive going forward. Now, let me just quickly go through some of the steps that we can use on this part of the methodology development, starting with load or extract. I think everybody is familiar with this paradigm in MarkLogic. You can load anything into MarkLogic as is, but then on top of that, to either extract the information or to enrich your data without modifying your raw data itself. The second step is to add additional indexes, being that a standard keyword-based index, or the new BM25 index, or the new vector-based index. You name it. You can support those different index paradigms as needed in MarkLogic. Lastly, once you have that, you can combine everything together, form different retrieval hybrid retrieval mechanisms, I would say. And what's even better is that with Gen AI, you don't have to manually construct these retrieval queries anymore. You can actually use the code generation capability of the language model to come up with a retrieval code, for example, using MarkLogic Optic API to formulate that retrieval mechanism code and to retrieve the relevant information. So combined together, I think that's really a lot of different opportunities on the retrieval side for us to use MarkLogic. Now let's move on to the second part of this talk. That is, how can we use MarkLogic to improve the AI agents? Well, AI agents, in case you haven't heard too much about it, it's really about how can we use AI in a more autonomous manner. It primarily relies on two mechanisms. One is give AI the access to different tools. Being that the tool could be, whether it's a look up a weather or run a Google search. But the second mechanism is to operate in a loop, giving AI the ability to have this self-feedback loop, so it can reflect on its own output and make incremental, iterative improvement over time. Again, in the context of AI for chemistry and for chemistry R&D, there's a lot of different opportunities. Shown here is a research paper recently published by, I think it's by the Pacific Northwestern National Lab, talking about how can you build an AI-based agent framework that can be used to cover a range of different tasks, ranging from literature understanding, chemical information extraction, to automate some of the informatics and modeling tasks. Another interesting opportunity is think about the knowledge graph, how it might be used for AI agents. We already know a knowledge graph is really good for retrieval. That's what the graph RAG about. But now think about, we can perhaps do the same thing. We can do more. One is, graph can also be a very good mechanism about thinking. Graph-based thinking could be another thing very useful for more advanced agent planning. Another thing is, we can use knowledge graph for some of the modeling tool management. Imagine, remember that we talk about we need to give AI a lot of different tools so they can expand their capability as agent. We can actually use knowledge graph to describe and manage those tools. Lastly, we can use a knowledge graph as a way to manage conversations. This is very important in the sense that when you want to deeply personalize your engagement with the AI chatbot. Having that conversation history managed properly is very critical to provide the right context for the right conversation. So with that, I'm talking about several of my thoughts about how MarkLogic can be quite interesting in addressing some of the opportunities. First is, again, this graph-based query capability, both including the knowledge graph query as well as the graph analytics-based query, such as the shortest path algorithm, could be very useful to enhance AI reasoning capability. Another area is, as I mentioned, for AI tool management and orchestration. Let's say if you give AI 5 tools, doesn't matter, just give all the tools to AI, let it figure out. If you have 500 tools to AI, you cannot afford to give all 500 tools. You will overwhelm AI. In fact, you will overwhelm a human as well. So we can use MarkLogic to intelligently select the right tool for AI in the right context. Essentially, this is a graph rag problem that's get used for tool selection for AI agents. Lastly is MarkLogic memory management. Again, this is essentially the same idea as using a graph or hybrid RAG system, but instead of based on documents, we're talking about retrieval based on memories, long-term memory. When you engage with the AI, we want to bring back the right memory, the right context whenever you have follow-up discussion. So that you never misappropriate the context or lose the context. Here's some of the work I did here as a quick proof concept. Again, the first one is using knowledge graph for tool orchestration. We have the ability to use knowledge graph as implemented in MarkLogic to orchestrate different use of different tools. Oh, sorry, I think there was a typo. The first step is actually for planning, AI agent planning. Let's say if you have a task, a complex task, you want to break down into individual steps. We can use MarkLogic knowledge graph to help with that planning phase. The second step is for tool orchestration. In the context for us, when we have lots of different cheminformatics tools, we can use knowledge graph here to select the right tool for different purposes. Now, I have talked a lot about different possibilities and different ideas. Now is the time for us to take a look at demo and see. Hopefully, that will give you some inspiration about how all of this can be possible. So what I have here is a quick demo that I built up, again, based on Progress MarkLogic, a little bit based on Semaphore, as well as using the Progress Kindle UI. So everything is actually within the Progress portfolio. If you like to try something on your own, you can do that using entirely based on Progress solutions. As you see here at the very top, I have different tabs here. Right now, I'm on the document tab because this is where I just want to let you know that I feed a bunch of different research-related documents into my database, including scientific articles, some patents, as well as some internal technical reports. Those are some of the very typical document sources scientists will interact with on a daily basis. First, when we ingest those documents into MarkLogic, we can have them ingest as is, but then we can also, on top of that, to enrich them, such as adding extracts, such as extract metadata, as well as assign them keywords, tagging, so on and so forth. And that is exactly what I did here. Every document here have the proper metadata extracted, as well as keywords assigned. But we can do more. For example, with a capability such as template-driven extraction, we can selectively extract useful information from those papers, patents, and documents. For example, in the context of chemical information, we may want to extract chemical synthesis information from different patents. so that we know in this particular pattern what are the different molecules that get used as ingredients for a reaction, what are the product for the molecules, so on and so forth. And then we can use that to extract molecular information combined with the external data source, such as such as PubChem database, so on and so forth, to really have a unified view of all the chemicals that are relevant to our research. And this is what you see here. I'm having a list of different chemicals with all this related information as well as the source where they appeared in my database. Now move on to the next tab is the graph. Here, this graph is primarily a taxonomy-based graph where, if you recall, I have the different keywords. Those are all based on this taxonomy that, if you like, you can create those taxonomy by, in Semaphore, either manually or today you can also use some AI-assisted approach to do so. And with each of the document, I can also, as part of the knowledge graph, have the relationship between the keywords and the documents associated with those. Next, we're going to move on to the tools. Tools, as I said, are different tools that we gave the AI to extend their capability. In this particular case, I have tools specifically for different R&D domains, such as biology, chemical, material science, so on and so forth. As you can see, even for this demo, I already have close to 3 dozen of different tools, and that's not possible to give all of them to AI Advanced. So by using the knowledge graph, we can intelligently group the tool as well as to manage their dependency. So for example, one tool must be used before another tool, how the output of one tool is getting used by several different tools, whether any incompatibility between different tools. All those different features will allow us to filter the right tools and give them to the AI in the right context. Lastly, what gets put all this together is agent. Agents are specialized design AI applications, essentially, that equipped with the different tools allows you for different tasks. For example, in the R&D space, we may have agents to calculate molecular properties, or agents to work on synthesis, chemical synthesis, or material synthesis, so on and so forth. Here, I'm going to choose this synthesis planner tool. This essentially is a task that's very relevant for both chemistry and the pharmaceutical industry. Suppose you have a new molecule that is a drug candidate, or it could be a new pesticide, or it could be a new ingredient that you're going to put into your product. Then you will want to know how to make that molecule. Not just scientifically possible, but also you want to make it reliably, economically, as well as make sure you don't hit any regulatory snags. This particular agent is designed to help assist you in this process. Let's say I have this sample query that I'm going to use to fire up my synthesis planner agent. The first step, as I mentioned earlier, is to use MarkLogic and knowledge graph information to help me plan this AI-based task. What are the different steps I should go through to accomplish this mission? Now that we have the plan in place, let's go through them one step at a time. The first step is called target normalization. This is essentially just to say, let's harmonize all the different terminology we might be using to describe this particular molecules. As you know, there are many different ways to describe a similar molecule. So in the first step, I have this AI using this agent to search a bunch of internal and external databases to find out all the different possible names for the target molecule, so that I can ensure that I include all the different synonyms as well as identifiers into my subsequent search. Now I have all the terminology harmonized, identified. I can dispatch my search now. What's shown here is a list of search results, as well as some highlight, some of the snippet or chunks that's relevant to to my question. Now, how do we actually accomplish this search? I did not run the search myself. I did not write the search query myself. What I did is first, I asked AI based on my my question and the information I have already gathered so far to come up a search strategy. This is essentially have AI to formulate its thought process. How should AI tackle this problem? By defining this multiple step approach. Next, I asked AI to actually write a opt API query to execute this particular search strategy on its own. Of course, this is not something that's always going to work. Sometimes it works. Sometimes AI will struggle. But again, you remember that self-feedback loop that you can always, when AI struggles, you can always give that feedback to AI so it can improve iteratively. But with this search query build, and that's what you see eventually in this particular search result. Now that I have gathered all the relevant information from my database, the next step is to actually extract the relevant information for my question. In this case, because I'm interested in how to synthesize or make a new molecule, I want the information present in a tabular format, such as what are the relevant chemical reactions I have access to? What are the different conditions? What are the different sources? So I can use AI to help me pull all the information in a tabular structure out of all the free-form text that I gathered and be able to retrieved earlier. And that's what you see here. The AI was able to identify a list of possibly similar reactions, either based on similar structure or based on similar terminology. Next, since now we have all the relevant information, we can put them all together, have AI to give me some suggestions in terms of how I should be making my molecule. And just within a short period, AI is able to provide several suggestions. I guess there are 3 separate suggestions based on the information that we have curated over the last several steps. And this will, by now give me some good, give the scientists some very good idea about how they might want to approach that. But we didn't stop here because there is one more step. That is to be a responsible chemist. We want to make sure that the approach that we're taking are not going to harm the society, are not going to create a safety hazard to the chemist. And that's when we're going to run all those different reactions, their ingredients, through a safety and regulatory assessment process, again, orchestrated by AI to let us to flag out all the potential issues. Here you can see that there are certain, AI has already identified certain issues for some of the domains. For example, there may be toxicity concerns. There may be flammability concerns. Again, not to say those are showstoppers, but those are just something that when we bring all the information in front to the scientists, they will be able to make a more informed decision. Lastly, it's the step of generating a final report. This is essentially just a Word-based document that combines all the information we have gathered and deliver to the scientists so that they can use the information to proceed with their research activity accordingly. So that is a very quick demo of this particular idea of using MarkLogic, multi-model database, knowledge graph, AI agent in a way to orchestrate different AI workflows for R&D. And as I said at the very beginning, I really deeply believe in the possibility of an AI agent in accelerating R&D. And I will welcome you have any questions or follow-up discussions. With that, thank you. Thank you for your time.
Thank you. Hi, Fan. Thanks for the talk. So you're building essentially an agentic AI on top of MarkLogic, which is really cool. One of the things you talked about in there was if you get bad results, perhaps in code generation or something, there's a feedback loop that you can use to make it better. Can you talk about your thoughts on how to implement that in a MarkLogic context?
So the feedback loop is essentially if you have used, for example, GitHub Copilot in VS Code, that is essentially the same mechanism. The AI will generate some code, and you can try to run it, and if it doesn't work, you give the feedback to AI, it will improve over time. This will be the same idea, having AI generate that search query in the form of Optic API JavaScript code. We can run the query and then provide some feedback.
So is that in the context of the same conversation or task run, or is there a longer-term memory aspect to it?
Yes. So every time when the model failed in various ways, we will feed that entire history back to the AI.
Okay.
So it will remember all the mistakes it made.
Thanks. I noticed in your putting the query together, you were creating a embedding on something like esterification of benzoates. What kind of resolution in the chemical domain do embeddings give you? What is a different reaction in the embedding world?
Right. So if we're talking about create a vector-based embedding for chemistry, for chemical structure, there are several approaches. I think typically what people use is either a fingerprint-based approach to extract relevant information, features from different chemical structure and create an embedding based on that, such as Morgan fingerprint. I see that's still the primary way to do that. I see there's some research about creating embedding based on raw molecular structure, but I think the fingerprint-based approach is still the mainstream.
Okay.
And I've seen people do that on scale. For example, in drug discovery, people want to screen millions or billions of virtual molecules, and it seems to be there are technology can do that fairly quickly.
Thank you, Fan.
All right, thank you. Thanks again.